transformation for a frame element. Of course, we can also do it for other elements, but I'll do it with frame elements because it has all the different kinds of degrees of freedom attached to it. Now we already know that for a truss, for a 2D truss, the transformation matrix T was given as cos theta, sin theta minus sin theta, cos theta, cos theta, sin theta minus sin theta, cos theta, where this row corresponded to UI1. So basically I'm going to write it as UIX. This was with UIY, this was with UJX, and this was with UJY. Now what has happened with the frame element? What's happened with the frame element? At each node, you have a UIX, you have a UIY, but you also have a UIZ, which is the out of plane. And this UIZ is nothing but, actually I shouldn't draw it like this, but like this. So this is UIZ, which is actually acting about the out of plane axis Z. So if you look at the transformations, that means, let me draw this out again. If I have a certain element lying in space at a certain angle with respect to a global axis xy, where its local axis is xy, then it has an angle theta, then the UIX and UIY are rotated by a certain angle. But the rotation doesn't need to be rotated by any angle. That means it always remains the same despite any transformation, because the out of plane axis is the one, it is the rest of the axes are rotating about. Therefore, if I have displacements UI1, or let me write it as UIX, UIY, UIZ, which is basically rotation, UJX, UJY, and UJZ, which is also a rotation as a vector, then I need to multiply a transformation matrix to get the global displacement vector, capital U. So the transformation matrix in this case is quite simple. We are going to pick up the terms that we use for the trusses. That means we will have cos theta for UIX minus sin theta for UIY, 0, and we don't have anything for UIZ, of course, on this particular line, and then there's too much space, so we need, of course, a 6 by 6 matrix, so 1, 2, 3. In the second row it is the same, so we have sin theta, cos theta, and no other transformation. In the third row corresponds to UIZ, so you have UIZ, which always remains in the third row or the third column, and it remains the same because it has no transformation, so it just replaced by a 1. Then you have the next node, and here you will have cos theta minus sin theta 0, and nothing here, sin theta, cos theta 0, and same way we know that it won't change anything for UJZ, so we just add a 1. So this becomes our new transformation matrix T for a frame element where you have 6 degrees of freedom in the system, where there's 1 axial degree of freedom, 1 transverse degree of freedom, and 1 rotation at each node of the element.